Okay, I want to take you through section 6.6. Hopefully my voice will hold up. This section is very important. We're solving equations. We have exponential equations to solve for and logarithmic equations. So the first type, the easiest type, is when I give you an exponential equation where the bases are the same. So if the bases are the same and all you're doing is you're going to set the exponents equal to each other. So for this to be able to figure out what x is, to make both sides equal to each other, I take my exponent. The one is 3x, the other one is x minus 4, and I solve that real easy equation. So I bring my x's together. So I subtracted 1x on both sides, and then now I need to divide by 2, and I'm going to get an answer of -2. Okay, and how you can check is if I substitute -2 in, on the left, I'll have 6 raised to -6, and then on the right side, -2 minus 4 is also a -6. So obviously 6 raised to -6 is equal to 6 raised to -6, so it checks. Okay, so that's just a quick little check. You should always check your equations real quickly, especially on your test, to make sure you're doing them correctly. Okay, that you didn't make a silly mistake. Here, both sides, the bases are e's. So I take 5x plus 2, set it equal to 10 minus 3x. Okay, and again, super easy to solve. Everybody in here can solve for x. I add the 3x, bring the x's to the left, get my number on the right, divide, and x is 1. Okay, and if you plug it in, you'll have e to the 7th equals e to the 7th. Okay, so those pretty easy. Big ideas will have problems like that. Now, if the bases are not the same, you're going to need to rewrite it so that both bases are the same value without changing the equation. Okay, so I'll show that. I'll show you a problem later like that. This one, now, here, the whole key is we don't undo a base by dividing. Okay, the worst thing you can do is think the answer is 9, and all you have to do is divide by 10. That would be correct if it was 10x equals 90, if it was a linear equation. This is an exponential equation. So what we're going to learn is we undo bases by taking the log of that base. Okay, if I simply rewrite this in logarithmic form, it's log base 10, which is the common log, of 90. And remember, logs are equal to exponents, and that's what I want to find. Okay, so all I need to do is go to my calculator and ask for the common log of 90. And again, if you think about this, you know it's an answer between 1 and 2, because 10 to the first is a 10, and 10 squared is 100, which is too big. So it makes sense that my answer is going to be in between, closer to the 2, and round the 3 decimal places. So 1.954. Okay. Now again, if you round and you check your answer, hey, 10 raised to the 1.954, just be aware it's not going to equal exactly 90 since I'm rounding. Now if I pasted this in, it would, but I'm going to be real close to 90 equals 90. Okay, so just be aware with rounding. Now, if your base is not isolated, you need to undo things so that the base, whatever the base is all by itself. So in this case, I have to add 2 first. So it's going to be 35. My voice can hold out. And so now I have to take the log base 9 of 35 to figure out my answer. Okay, so again, we're just going to rewrite this in logarithmic form, and everybody in here knows how to use the math key. And then base 9 of 35. Once again, it's going to be between 1 and 2. So calculator tells me it's 1.61, and I'll keep it as an 8. Okay, easy. Remaining 4 on this page. My base, here's number 5. My base is 5. There's nothing outside it, so I don't have to undo anything. So what I'm going to do is take log base 5, since my base is a 5, of 42, and that's going to equal 7x. Okay, so once I do this in the calculator, I have to divide by 7 to get the overall answer. So once again, math key, go to log base 5, 42, and then I'll write this just to show the notes. It's 2.322, and I would just keep that stored in my calculator, okay, equals 7x, and then when we divide by 7, we'll get the overall answer. But don't just keep this stored in your calculator, divide by 7, and you're going to get an answer of about 0.331 for x. Okay. Oh, actually, I should round that to a 2, sorry. Because next to 1 is a 7, you round up. Okay, so 0.332 is a good answer for that. Okay, now base E, log base E, we learned that it's simply the ln. So the ln of 22 equals my answer. I simply type in ln, so the ln button, and 22, and you're going to get x equals 3.091. Okay, last two. Your base is an E. Your base is not a 4E. Okay, if I wanted my base to be a 4E, I would have to wrap it in parentheses. So since we don't have parentheses, you must divide by 4. Okay, so again, force that to make sense. And when you're doing big ideas, please show your steps. Okay, write it on paper and make sure you understand the steps to get the correct answer. So e to the x equals 6. And now it's real easy to undo the base e by taking the ln of 6. And if you take your calculator, ln of 6, 1.792. Okay, should be easy. Okay, you'll have plenty of practice with this. When you do the practice exam, same type of problems that you're going to see on your test. So again, force yourself to understand my base is E. Now I have two numbers I have to undo. I have to undo that plus 8. Everybody knows we subtract an 8. So I have 2e raised to the x equals 32. Don't forget to divide by 2 first, okay? So your e to the x equals 16. And now my last step to solve for x, we know x is really going to be the ln of 16. So I'll write ln of 16 equals my exponent. That's all logs are. Logs are exponents. I'm trying to find the exponent. So the calculator knows ln 16. We're going to get about 2.77, and we'll round that third decimal place to a 3. Okay? So that should make sense. Okay, this next part are logarithmic equations. Okay? So very similar. Easiest is when you have the log base on both sides of the equal sign. You can just cross those out, and all you have to do is set the 6 minus x equals negative 2x plus 8. Again, the bases have to be the same. Just like with exponential, the bases must be the same. And so what I'm going to do is add a 2x. So if I add a 2x, I'm just going to be left with an x on this side. When I subtract my 6, I get x is 2. Okay, and you can plug it in. If you plug it in to check this side, you're going to end up with log base 4 of 4. And then the other side, you put negative 2 times 2 is negative 4 plus 8 is also going to be a 4. And obviously, they're the same answer. 1 equals 1. That's what it becomes. So there's my little check. Now, I'm going to teach you something later on. So the reason I'm allowed to cross out the ln's, or we have ln on both sides, there's something called exponentiating, which I'll go over. Whatever the base of the log is, you can write underneath. So I'm going to write an E underneath each of these. So whatever you do to one side, as long as you do it to the other, equation stays balanced. And these are inverses of each other. They just wipe each other out. And we're left with 4x minus 1 equals 15. Super easy to solve. Add a 1, 16, divide, and you get a 4. Okay? So it's the same as rewriting this in exponential form. Okay? So we'll see that with this problem. So now I don't have log on both sides, so I need to undo a log base 9. So to undo this, we can simply rewrite this in exponential form. So I'll do that method first, then I'll show you exponentiating, and you have to decide which method you like. So if I give you a logarithm and I want you to write it in exponential form, here's what you do. 9 is the base. The exponent, logs are equal to an exponent, so my exponent is a 3, and it's going to equal, in this case, just an x. Okay, so as soon as I ask the calculator, hey calculator, what is 9 cubed? I have my answer. It's going to be 729. Okay, so you have a choice between rewriting it in exponential form or exponentiating, which I'm going to show you in the next problem. Okay, and again, ask the calculator. You can always check this on a test. You do log base 9 of 729, I promise you, is a 3. Okay, so some students like this method. Easy way to rewrite this is to undo the log by exponentiating. So it's log base 8, so I write an 8 underneath the log, and then on the other side, you write your 8, and what you need to realize is 8 is your base. Negative 2 is the power. So this really means x equals, because I undid the log, x equals 8 raised to the negative 2. So if I ask the calculator, 8 raised to the negative 2, you're going to get a decimal. So here's the decimal. But math enter, I'm hoping you realize it's just a reciprocal of 1 over 64. Okay, so I prefer 1 over 64 than the decimal. Okay, so number 13, my base is 6. So it's really 6 raised to the 1 power equals x minus 2, but I'm going to exponentiate, so I'm going to put a 6 underneath each side, okay? Don't think that it's 6 times 1. 6 is the base, 1 is the power. So that wipes out. X minus 2 equals 6 to the first, which is simply a 6. Add your 2, and 8 is the solution, okay? For ln, our job is to know that ln is log base e. So I'm going to put an e underneath each side. It wipes out the ln. X equals e squared. And I'm simply going to ask, just to round to 3 decimal places, second ln. And I'm going to ask the calculator to square it. So we get an answer of about 7.389. Okay, my voice is somewhat holding up. I was worried that I couldn't get through all my classes, so this is why I'm recording. So I'm hoping that I can do this. ln is base e, so I'm going to start by undoing that. Wipe it out, it's gone. And 2x minus 3 equals e to the first power. So now, here's the steps to solve for x, and I'll do this all on a calculator then, but I want to show you the steps. I have to add a 3, and then we have to divide everything by 2. Okay, so let's do that on our calculator. So here's my calculator. My first thing, second ln, the e appears. I raise it to the 1 power, and I'm going to add 3 right away. So I'm going to hit enter before I divide by 2, because order of operations, I need to add a 3. I get that decimal, and then my last move to solve for x would be divide by 2, and then you get about 2.859. Okay. There you go. Okay. The next one, you're supposed to recognize that it's base 10. Okay, undo this. Can't just cross it out. I have to do something to both sides to undo a logarithm. So log is base 10. So I put a 10 underneath each side. The log is gone. I still have a quadratic. So we have to remember how to solve a quadratic. And then another thing that you need to realize is 10 to the 0 power. That's what it is. Not 10 times 0. It's 10 raised to 0 power, which is going to be 1. Okay? So then to solve this quadratic, all that's left is a regular quadratic that we've been doing since chapter 2. We simply get 0. So I'm going to have to subtract that 1. X squared minus 8x plus 12 equals 0. Two sets of parentheses, x and x. I know it's minus minus. Ways of getting 12. 3 times 4, that won't work. 12 times 1 won't work. But a 6 and a 2. Okay, so those are the factors. Then write your answers. What makes x minus 6 0 is a positive 6. And a positive 2 is what's going to make the factor x minus 2 equals 0. So my two solutions, so I can plug in a 6 in here or a 2, and I'll get both sides to be 0 equals 0. Okay? So 17 and 18, we end very easily because we see the same log on both sides of the equal sign. So technically the move is exponentiate with a 2, the logs are going. 3x plus 2 equals 4x minus 9. X, add, and you're going to see, you're going to get an answer of, excuse me. Did I do that correctly? Oh, it's going to, if I bring this over, I'm going to add, it's a positive. Okay, so I added my 9, it's a positive. 11 is your answer. Again, super easy to solve. Okay, this one, I put an E underneath each side. That's a legal move to be able to get down to negative 14x plus 3 equals x squared plus 43. It's a quadratic, so I need 0. So I'm going to keep my x squared positive. Okay, I always like keeping the x squared positive. I'm going to send the negative 14x over to the other side, and I'm going to subtract the 3. And we should be left with a pretty easy trinomial to factor. I know everything's positive, and my brain already told me how to get a 40 to add up to a 14. I know it's a 10 and a 4. Okay, so you don't give up until you can find the combination. And therefore, negative 10 is a solution, and negative 4 is a solution. Okay, so then I need you to try. Okay, before you even do big ideas, you want to make sure, I can get to this page, try these problems on your own. Okay, go through them, look at to see what type it is. So like here, my bases are the same, set your exponents equal to each other. Here we undo or rewrite that as log base 3 of 11. Type it into your calculator. Okay, so make sure you can do these type of problems, and then try the big idea assignment. And like I said, on big ideas, you're going to see an example like this. So I just want to show you one quick example to add to your notes up top here, where what if my bases are not the same? So if your bases are not the same, like a problem like this, I have 5 raised to the x minus 3 equals 25 raised to the x minus 5. Okay, so right now bases are not the same. I can't just set these equal to each other. That would not be the solution. So what we need to do is rewrite this without changing the value of anything, without changing what the original equation was asking, so that both bases are the same. Well, hopefully you realize 25 is nothing more than 5 squared. Okay, so I can keep this side as is, but then the 25 really becomes 5 squared. Okay? Everyone should know that's 5 squared raised to the x minus 5, and that's that power to power then. So I just multiply my exponents. Okay, so now the bases are the same. You basically undo a base by taking the log base 5 of both sides. The 5s would be gone, and I solve this. Okay, so it's a real easy problem to solve. You'll get an answer, and in this case, you'll get an answer of 7. Because if I subtract, add my 10, I'll get x equals 7. And it's really easy to check. 5 raised to the 7 minus 3 is going to be 5 to the 4th power, which is going to be identical to 25 squared. Okay, they're both 625. So make sure you spend some time looking over these problems. And then the last thing, and I'll do this later, and I actually will have another video on if you see problems with logs on the same side, we must condense. Okay, so I'll post another video about condensing first. Okay, but that'll help you complete all the problems and big ideas. It will also help you be able to solve the equations that I have on the practice test. Okay, so this is something that takes some practice. Thank you for watching. I apologize with my voice, but hopefully I'm getting better. It's better than yesterday. So thanks for watching. Take care.